In this video, we'll take a look at section 4.4, trigonometric functions of any angle on the coordinate plane, not just the unit circle. So we've already taken a look at a circle. If we had a unit circle with radius 1, then the values of the x and y coordinates were the sine and cosine of the angle. So let me bring up the unit circle. So these coordinates. So what if we have a coordinate that's not on the unit circle? What if it's out here? We know that it's on the terminal side of the angle, but it's way out here somewhere. So that's what this section does. So let's say that we have a circle that's not radius r, and we have an angle in standard position that goes through a certain point xy. You can still think of this as a right triangle, except our radius isn't 1 anymore. The x value is one of the lengths of the triangle. The y value is the other leg length of the triangle, and then we have to find the radius. So looking at this triangle, the sine of our angle opposite over hypotenuse is y over r. Cosine is adjacent over hypotenuse, x over r. And then we can get all of the other trig functions using sine and cosine. So what the definitions are for sine, cosine, tangent, cosecant, secant, and cotangent, they're all defined in terms of the x and the y coordinate and the radius of the circle that terminal side of the angle goes through. All right, so let's take a look at an example. Our first example says, let our point P equal 1, negative 3. So let me graph that point, 1, negative 3. And let's say that's a point on the terminal side of an angle. All right, so our angle would start in standard position and rotate. So here's our angle. And this is the coordinate 1, negative 3. So if we think about it, that's definitely not a radius of 1. So what we could do is we can drop a perpendicular to the x-axis and make a right triangle out of it. And then think about it in terms of lengths of a right triangle, or trig functions. The little short side right here has length 1. The long side has length 3, and I'm going to label it as negative 3. And we can use the short side and the long side to find the r, which is the hypotenuse. So we use that r squared, I square root both sides. R is equal to the square root of 1 squared plus negative 3 squared. So r is going to equal the square root of 1 plus 9, which is 10. That can't be simplified. So I have a value for x, which is 1, a value for y, which is negative 3, and a value for r. So think about them as the three sides in a right triangle. Now I can find all 6 trig functions by using the relationships above. So the sine of my angle is going to equal y over r. So that's going to be negative 3 over the square root of 10. Rationalize your denominator. We end up with negative 3 square root of 10 over 10. The cosecant of that angle is the reciprocal. So let's go r over y. That's going to be the square root of 10 over negative 3. Cosine of the angle is going to equal x over r. So that's 1 over the square root of 10. Rationalize the denominator. We get square root of 10 over 10. Secant is the reciprocal. That's going to be r over x. So that's square root of 10 over 1, which is the square root of 10. Tangent, several ways to get there. You can take sine divided by cosine, or you can take y over x. So we're going to get negative 3 over 1, which is negative 3. And cotangent is the reciprocal, which is x over y, which would be 1 over negative 3. So those are our 6 trigonometric ratios of that angle, or that is not on a unit circle. So what do? We draw a right triangle basically and find the radius, or the hypotenuse, and that equals the radius of the circle. All right, the next question, quadrantal angles. It says evaluate the cosine function and the cosecant function at the following 4 quadrantal angles. So this is something that we can do using our unit circle. but we'll just reiterate here and use, let me draw in an axis. So 0 degrees in standard position is right here. I'm just going to pick a radius of 1 because I don't have a coordinate to go through, so I'm going to use that as what, 1, 0. So for A, the cosine of 0 degrees, let's see, if that's 1, 0, the radius is equal to 1. So the cosine is equal to, let me come back up here, cosine is x over r. X value is 1 divided by the radius of 1, so that would be 1. The cosecant of 0 degrees, back to the formula up here, the cosecant is r over y, when y is not 0. So the cosecant would be r over y, but in this case, if r is 1, the y-coordinate is 0, so that there is no cosecant of 0. That's undefined. Part B, let's see what happens at 90 degrees. We want the cosine of 90 degrees and the cosecant of 90 degrees. Our coordinate this time at 90 degrees is 0, 1. So the cosine of 90 is x over r. X is 0 over 1, which is 0, and that's legal to have 0 in the numerator. The cosecant of 90 is r over y, so that would be 1 over 1. So the cosecant of 90 degrees is 1. Part C, for 180 degrees, we want the cosine and the cosecant. Coordinates over here are negative 1, 0. Again, the radius is still 1. So the cosine is x over r, so that would be negative 1 over 1, which is negative 1. And the cosecant of 180 is r over y, so that would be 1 over 0. It's undefined again. So there is no cosecant at 180. D, the last one, at 270 degrees, our coordinate is 0, negative 1. Cosine of 270 degrees, x over r, so we get 0 over 1, which is 0. And the cosecant is equal to r over y, so that would be 1 over negative 1, which is negative 1. You could have also used, we basically used the coordinates on the unit circle. All right, last couple of examples. Checkpoint 3, if the sine is less than 0, so that tells us that the sine is negative, and the cosine is less than 0, name the quadrant in which the angle theta lies. So where are the sine and cosine both negative? Remember that cosine is your x-coordinate, sine is your y-coordinate. So which quadrant? The first quadrant, you have both positive x and y. Quadrant 2 has negative, positive. Quadrant 3, x and y coordinates are both negative, so sine and cosine are both negative. And quadrant 4, cosine is positive, sine is negative. So this is going to land in quadrant 3 because the sine and the cosine are both positive. All right, last example, we're given a tangent of an angle is equal to negative 1/3, and the cosine is negative. Find the sine and the secant. All right, so the tangent and the cosine, we have to figure out what quadrant we're in. So where is the cosine negative? Cosine is the x value, so cosine is negative in the second quadrant, and the cosine is negative in the third quadrant. We also know now that the tangent is negative. Remember that tangent is equal to sine divided by the cosine. So in order for the tangent to be negative, the sine and the cosine have to have opposite signs. So in the first quadrant, they're both positive, so the tangent's positive. Second quadrant, cosine's negative, sine's positive, so here the tangent is negative. Third quadrant, the tangent is positive. Fourth quadrant, the tangent is negative. So the tangent is negative 1/3, cosine is negative, that tells me that I'm working in the second quadrant. So next part of it, I know that the tangent is equal to negative 1/3. So think about this in terms of drawing a triangle. I'm going to draw, I know my angle is somewhere in the second quadrant. This is my angle. So I'm going to draw a right triangle by dropping a perpendicular down to the x-axis. So I'm going to think about this angle right here and this triangle as being kind of a reference. It's actually a reference angle. So if the tangent is negative 1/3, opposite over adjacent, opposite is 1, adjacent is 3, and then to get a negative 1/3, one of these must be negative. The x-coordinate in the second quadrant is negative. So I have a triangle, and I know that one side is 1, one side is negative 3, and now I want to find the length of that hypotenuse. So I put it in Pythagorean theorem, so I'll call that r, is equal to the square root of 1 squared plus negative 3 squared. We did this very similar up above. So that ends up being the square root of 10. Now that I have my triangle, I can find the sine of the angle, which would be opposite over hypotenuse. So that's 1 over the square root of 10. Rationalize the denominator. I get square root of 10 over 10. And I want to find the secant, which would be 1 over the cosine. Or remember that cosine was what? X over the radius. So this is going to be the radius over x. So I get square root of 10 over negative 3.